Hi, my name is Sebastian Matteau and this is the first of a three-part video series about object-oriented programming in Python. Now, Python is a very strongly object-oriented language, which means that if you've done a bit of Python programming, then you've also done a bit of object-oriented programming. But I know that a lot of people are still quite hazy about the exact concepts behind object-oriented programming. So the goal of this video series is to give you a very firm, but firm understanding of what object-oriented programming is, without going too much into the details. And in this first video, I will start by introducing the most important terminology. So let's start with the class. What is a class in object-oriented programming? A class is an abstract concept, an idea, a category of things, something abstract. A good example is an int class in Python. An int corresponds to all the idea, the concept of integer numbers. A specific integer number, like 7, would not be a class, but the general concept of an integer, that's a class. A dict is also a class, so it's the general concept of being able to map keys onto values. There are specific dicts, dictionaries, that for example map an X onto a 1, that wouldn't be a class, but the general concept of a dictionary, a dict in Python, that's a class. So the int and the dict are built into Python, right? They're standard classes, but you can also create your own classes, and I did that for this video. And in the next video, I will show how I did that. So I created the number list class, and that corresponds to the general concept of a list of numbers. And you see, I also followed the capwords naming convention for class names, saying that you should probably use an uppercase first letter of every word and lowercase for the rest, to basically visually indicate that something is a class. You also see that the dict and the int themselves actually don't follow that convention, so it's a little bit inconsistent, but most modern classes actually follow this capwords convention, and if you see something that is written in capwords, then you know that it's probably a class in Python. So let's just start by importing my class. So I made a module, I called it number underscore list, right? So that's again a naming convention that modules have this sort of lowercase underscore notation. And from that module, I import the number list. And then I click here or press F9 to run this. And then here on the right, you see in the console, it got imported. Number list. And you see I imported it. So this is a class, my number list class. So let's now move on to the concept of an object. So an object is a concrete instance of a class, and there can be multiple objects of the same class. So a few examples are, for example, 1. The number 1 is an object or an instance of the class int, and so is the number 3 and the number 5, etc. So you see how they are different, right? An object is a specific instance of a general concept, and the general concept is the class. Then you have this particular dict that maps an X onto a 1. That's an object, and its class is a dictionary, a dict. And the number list, I wrote it like this here, can also have an object or an instance, for example, consisting of a 1, 1, 2, 3, and 5, which you might recognize as the Fibonacci series, the first 5 numbers of the Fibonacci series. And a naming convention is for the object names to use this lowercase underscore notation, right? So this corresponds. This is capwords, corresponds to the name of a class. Then if you make a specific object, you use the lowercase underscore notation so that you can tell apart visually what the class names are and what the object names are. So let's start actually by saying, okay, Fibonacci. So now I will make a specific instance of the number list, an object called Fibo. I can make multiple objects, right, of the same class. So I can also say primes is also a number list. But then it's the prime numbers. Which prime numbers? 2, 3, 5, 7, and 11. I hope that those are correct, otherwise I will hear it in the YouTube comments. Okay, now I press F9 to execute this. Up. And here in the console, now you see that I have my Fibo object and my primes object. Right, so the number list is the class, and Fibo and primes are objects of that class. Okay, up. Now, the type, and I already basically said this, the type of an object is its class. So if I say type, and type is a function that is built into Python. If I say type, and then an object, and then I select this and run it. Oh, no, F9. you will see that the type of Fibo is a number list, and that makes a lot of sense. Another function that you can use to test the type of a class is isInstance. So again, a function that's built into Python. If I say, is Fibo an instance of a number list? And I run that, then Python will say true. Fibo is an instance of a number list. So checking the type and using isInstance are quite similar, but they're not identical, because let's take a look at what happens if I say isInstance Fibo of a list. So list is just a general garden variety list that's built into Python. If I run this, Python again says true. Why is that? Well, that's because my number list is derived, is sort of a subtype of the general concept of a list. So think of it like this, right? I am an object, in a sense, and I am an instance of a man, but I'm also an instance of a human being. I'm also an instance of a mammal and an animal, etc. Right? So I'm an instance of a lot of general classes. And that is basically what isInstance tests. Whereas type gives you the most direct type, right? So what would be my type? Maybe, low level, my type would be a low level wannabe YouTube celebrity, something like that, right? But if I test with isInstance, there are a lot of different classes that I would be part of. If I test whether Fibo is an instance of a dict, as to give you a counterexample, then Python will say false, because the number list is in no way affiliated with the dict, right? So that's like asking whether I'm an instance of a reptile, for example. I'm not, right? I'm an instance of a lot of things, but not a reptile. Okay. Now, so now we've introduced a few terms. Let's say something about the style, programming style. So, a traditional functional programming style, which is different from an object-oriented programming style, is to make a very clear distinction between functions, things that do something, and on the one hand, and data on the other hand. That sounds abstract, but let me give you a very simple example. Say I say, from statistics, import mean. Mean is the function that gives the mean value of a bunch of numbers. And if I say Fibo mean is mean Fibo, and then I say print Fibo mean, I can run that, and then I get 2.4, which is the mean of my 5 Fibonacci numbers. So this is a trivial example, but it shows a functional programming style, because we have our function mean, and we have our data Fibo. We pass the data as an argument to the function, and the function does something, in this case calculate the mean, returns it, and that's how we do things. There's nothing wrong with it, right? This is a very decent programming style, but it is not object-oriented, and I'm giving it here as an example to contrast with an object-oriented programming style. So let's see how we could do the same thing in a more object-oriented way. So an object-oriented approach to the same thing would be this. Fibo mean, and the difference is subtle, but bear with me. Fibo.mean, print Fibo mean. Up. If I run this, you see again, I get the same output, 2.4. So what are we seeing here? We're seeing that we have our data, our object, Fibo. And rather than passing that object as an argument to some kind of function, the object has functions itself. And these functions that are part of the object, they're generally called methods. And in this case, my number list object has a function called mean.mean. And if we call it, it gives the mean value. We don't need to specify to mean anymore that we want to have the mean of the Fibonacci object, because that's implied, right, by the fact that mean is actually part of the Fibonacci object. And then we print it out. And what is different about this approach, you see actually it's very similar, right? Here we express the same logic here and here in almost the same way. But there is a slight but important difference in sort of how we emphasize the relationship between our data and our functionality. Here above, we have our functions that do something, and we have our data, and they're two separate entities. And for some cases, that's quite useful. Here below, we have, if you want to use an esoteric term, a more holistic approach, where our object has both the data in it, the numbers, and the functions to operate on those numbers. And that is a key aspect of object-oriented programming. It's sort of encapsulating functionality and data as one thing into an object. So, and a method is the general term for a function that is part of an object. There's also the concept of properties. So say that we want to see how many numbers there are in our Fibo object. I can do Fibo.length, run it, and you see it says 5. Length is a property, sometimes also called an attribute or an instance variable or a field. There are different terminologies, different terms that refer to the same thing in object-oriented programming, but Python people generally use the term properties. And a property is a value that is part of an object. So it's kind of like a method, but then it's not a function that you have to call, but it is just a value that you can get straight away. In this case, Fibo.length. Okay, so I think now we've seen the basic concepts of object-oriented programming. Classes, which are general concepts. Objects, which are instances, specific cases of classes. You can have the type of an object is its class, and an object is an instance of its class. We've seen that the method is a function that is actually part of an object, and a property is a value that is a part of an object. All right, in the next video we're going to take a look at how we can actually make our own class, and more specifically, we're going to implement the number list class. All right, thank you very much.